In the previous video, we introduced the notion of objects and classes. We looked at instantiating the object. We looked at maintaining the states of the object through the attributes. We manipulated the attributes through the methods and so on. Now, we know that we created quite a general class in that example. It was just some arbitrary animal. And yes, we could define the type of animal through the animal type attribute. We want to look now at inheriting behavior or methods from different classes. So in the notes here we say that not all animals can do the same behavior. So a bird can fly, which not all animals can do. An animal of a predator type can hunt, and not all animals can do that. So there exist, of course, animal subtypes, and these are behaviors that we can then create a class for. So, of course, we can create a bird class, and then we can attach flight behaviors, or we can create a predator class as well. And that's all fine. We can create a new class for those subtypes of animals, but we recognize then that there might be lots of duplication involved. So all the operations that belong to the general class of animal, we don't want to have to go and duplicate that each time we create a subclass or a sub-object or an object which is of a subclass type. And class inheritance allows us to do that. So this is the solution where we can create a class that inherits all the attributes and all the methods of the parent class, which we also refer to as the base class. And so we create this class which is actually derived from the parent class. So it's a child class or a derived class. And we do that as follows. So here we are now creating the class of type bird. And we note that the animal class still exists. So following from the previous video, this is the same Jupyter notebook and the same class definition exists in this notebook. So the animal class exists, and we are passing that as an argument to the bird class. And by the way, we noticed that before we didn't have arguments to our class definition. We did have arguments in the instantiation. So in our constructor, we had arguments, but we never had arguments to the class itself. So in class inheritance, when we want to extend a class, then we provide, it's not really an argument. This is really specifying that animal is the superclass or the parent class, and bird is now derived from this class of animal. And here we are adding this method of fly_to to the bird class. So bird will contain all the methods of animal. So a bird can walk to locations, it can report its location because it inherited that from its parent class of animal. But in addition to that, in this class, we are able to attach the fly_to method. And you'll see we are using the same as before. We are using distance parameters and so on. But we are doing that this time by flying rather than walking. And here in this statement, we are creating a bird. I guess the spelling it's poly. Let's not confuse with polynomial or something. So poly is a bird, and we can tell that bird to go and walk home. We can also go and tell that bird to fly instead, and we can tell it to echo location. And you see here in this class definition, this child class definition, we don't have these methods defined. Walk to and echolocation are not in this class definition, but they are inherently there due to this being extended from the animal class. So if we run this, it does work. It's able to echolocation in the same way that we're used to from the animal class. So this is now a child class with additional methods that are specific to the subclass. We can see here that the parent constructor is being called automatically. All right, so if you look at this statement, we have not specified the type, but here in the instantiation, we are sending in an argument. We are sending this bird here, this name. Now, in a way, this example is a little confusing. So when we're saying here bird, that's not entering this class as a parameter animal. Instead, the compiler is going to look up the bird class. It sees, yes, this bird class is actually a child class of animal. Therefore, let's run the animals initializer. So it will first look up the animals initializer, and the animal initializer will expect an animal type as its first argument in the constructor, and it has a default value for the second argument, so we don't have to worry about that part. So animal type will be given the string bird. So that's how we read this. We are initializing a derived class, and the argument that's sent in is used as the initializer to the parent class animal. So we get the animal type specified, and now because we've instructed this this object to be a bird, well, it could have been an animal. We have these methods, but now we also have the fly to method. So all this works. Well, I guess we've already seen that. So the parent constructor is called, but we can see that we can improve on this code. So if we know we want Polly to be a bird, we should be able to just instantiate it as a bird, and we shouldn't need to go and specify, yes, this is a bird, right? We shouldn't need to go and type this in as well, right? Bird should have that implicitly. And so the way we can do that is by setting ourselves a constructor for the bird subclass. And the way we've written it here, we are actually overriding the animal initializer. So here we are creating the constructor for bird. So bird is going to set its animal type as bird, right? So in contrast to the animal class, which accepts an animal type parameter in the constructor, we are simply going to assign animal type to be bird because we know it's bird. We are creating something of type bird, so we just specify the type as a string here. We are also initializing the distance as we did before. So this is an example of where we are creating a constructor for our child class, and we are not calling the parent constructor, we are not calling the constructor for animal at all. And so now we can use fly to and walk to and echolocation and all that as normal. So that is fine. However, there's scope to improve this further, because we recognize by stating this that we are duplicating code. Right? In our animal class, we had initialized the distance to 0. And so that animal class exists and is ready to initialize distance to 0. But now we've gone and written a setting of distance to 0 again. And of course, this is a very simple example, and it probably doesn't seem like a great cost to us to do that. But of course, there may be much more complicated initializations going on, and initializations that really should be done anyway automatically as part of this definition. So we can solve this problem. We can, instead of simply overriding the parent, we can create a constructor and call the parent constructor as part of this. And here's how we do that. So we are again creating this extended class, this child class bird, which has a parent class animal. We are creating the constructor here, and what we are doing here is calling on the parent. So the compiler knows that this class does have this parent animal. So when we call on animal here, it does know what that is. It doesn't throw out an error saying, I don't know what animal you're talking about here. It knows that we are referencing the parent class. And then we can reference the constructor for that parent class. So we know that to initialize the animal, we have to supply it with an animal type, and we have the option of specifying a location, but we know there's a default for that. This time, because we are calling the parent class, we have to specify the self. We have to give it a reference to the object that is being referenced as well. So this time, in contrast to when we initialize the animal, when we call its constructor explicitly like this, we have to specify the reference to our object. And now we know in the constructor to animal, it's going to specify the animal type. It's also going to initialize the distance traveled, and then of course we are going to absorb its methods. So this is the best way to create a child class. We create a constructor, and we also call the parent constructor. So when we run this, we can see we walk home, and then we fly to work, and we get the expected incrementing of our distance variable. So that's how we create child classes. Now, if you read around in the object-oriented literature, you'll find that the concept of multiple inheritance does exist. So you can inherit attributes and functionality from multiple classes. However, this can introduce some complexity. So you can get some ambiguous behavior, or you can cause ambiguity. And you can read about the diamond problem if you're interested in that. And so because of these complications, multiple inheritance is not really popular in object orientation. And of course, people who have spent decades in this field will want to shout me down for saying this, but it's not in the modern style of programming to use this style of programming anymore. We don't really use multiple inheritance that much. Other concepts you can read about: polymorphism. That's something that is used more. So sometimes you want your parent class to be able to reference the child class, and I've used that on a number of occasions for doing more automation, for really automating things quite strongly. So polymorphism can be useful. Abstract classes, those are other useful methods that it lets us specify what a class should have in its method space and among its attributes. And so when we use an object in some environment, then we can guarantee certain behaviors from that object, or we know that that object knows how to handle certain things. It can be used in certain ways. So an abstract class, it's another useful concept. However, the majority of object-oriented programming can be done by using single parent inheritance, and still it may occur to us, well, what if there are sets of behaviors that I want my objects to absorb? And there is a kind of cheat for this, right? It's not exactly a workaround. It does have an approach that we can defend on principle. So here's an example of that. Let's say we knew we wanted to create some subclasses of animal, for example, bird, as we've been doing. And let's say we also wanted to specify even further that some of these animals had some kind of athletic ability. So we can create this class called athletic ability. And among those abilities, we include somersaulting and cartwheeling. So, and I'm not doing too much in here in the simple example. I'm just printing out somersaulting and cartwheeling. So those are athletic abilities. And we simply attach that to the object that we want to add that ability to as an attribute. So we create an object within this object. So here, if I want to attach athletic abilities to all birds, then I can create an attribute of this bird, and I'm calling it athletic abilities. And I'm setting this attribute to be a new object of type athletic ability. So that means if I call on this attribute, then I can reference these additional methods. So that's how I can attach and inherit from another class, right? That's through an attribute of my subclass here. So now if I ask my polybird to somersault, I can do it this way. I can say, take out from your athletic abilities, call on your athletic abilities and somersault for me. And it can do that. Now, there's a complication that this introduces, right? In somersaulting, we can, what we've been doing so far is when we create a method, we return a reference to the object itself, right? When we said fly to, because we wanted to be able to chain our methods together. And remember, in the previous video, you can see, you can read about or listen to chaining. So in our methods, we were always returning the reference to the object. So we were returning self. But if we go and do that in this style, where we are trying to absorb the methods. Okay, sorry, I'll be along now. So now, if we are trying to do that here, we will not return the correct reference, right? We will return a reference to this class, athletic ability, and we'll have no way to reference ourselves back to bird, right? So athletic ability is a sub-object of bird, and it doesn't contain a reference to that bird. So once we say somersault, once we've done the somersault, the return from somersault, if we'd used just self here, it would only be to that attribute. So to get around that problem, what we can do is in athletic ability, we can say, well, I can see here, this is just going to be a set of methods. So I can attach this, I can expect that when I construct this, when I instantiate an object from this class, I will be attaching myself to some entity. So we can pass the entity as the argument to athletic ability. So here, when I'm adding athletic abilities to bird, I am also passing it the self. So I'm passing a reference to that bird into this class athletic ability. So the athletic ability object now has a reference to that bird through entity. So athletic ability can reference the bird. So now when it somersaults, instead of returning a reference to itself, instead of returning a reference to athletic ability, it can return the reference to the object that's calling for the somersault. So we reference the entity rather than the self. And so here, somersault returns that, and it returns the bird, and so now we can go on to use the bird's method of fly to. So that's why this works. Right, so that's how we can deal with inheritance and the sophisticated concepts in object-oriented programming. And this is really the modern style of dealing with it, right? We use single-parent referencing, and we attach and absorb abilities from other objects and other classes as we like.